Hello, hello. All right, we're going to get started now. We've got Josh Kuhn, our ecosystems engineer. RethinkDB, polling. There is a cure. All right, there we go. Thanks, Josh.
I changed the title at the last second, so they didn't know about it. Hi, I'm Josh Kuhn. I'm the ecosystem engineer, which is a weird title, but basically it's everything but the core database. So I do the drivers and the web UI and all kinds of fun stuff. So today I'm going to talk about a little bit more low-level stuff about the architecture of RethinkDB and why it's able to do the cool stuff that it's able to do. So, this is the usual blurb. It's the open source scalable database for the real-time web. And, Mike went over some of these things. One very important thing, we are AGPL version 3, so it's going to be sticking around. We have scalability built in, so our queries automatically convert to MapReduce. You don't have to change how you write your application when you add more servers and when you scale up, which is a really important feature. And we have sharding and replication as well, so that's the standard scalability features. So Mike showed you how the real-time web works, how what Slack looks like, how you build an app with RethinkDB. The idea being, you push and you don't poll. So on the front end, basically web browsers have solved this aspect of the equation really well. We've got server-sent events and WebSockets. You can do long polling. I don't like that because it says polling the name, but really it's like TCP polling, so it's really efficient. But anyway, so the front end from your web server to the browser is solved. They've got real-time push stuff. Web application servers, they get, Node and Go have real-time application, they're built with that in mind. Tornado, Twisted, Event Machine. Basically, if you're writing a web application today, you probably have a framework available to you in whatever language you're using to do real-time. So the database is the part that's really missing. So can we end polling in our lifetimes? That's the question. Adapting the database is actually sort of a challenge. It's the same challenges you usually have to deal with at the application layer, where you're having to figure out where all the messages are going and which parts of it you care about. And so instead, we have to solve them in the database itself. So one interesting thing, one aspect of this is really hard to get databases to scale is how many connections can you make to your database? Even if your database is able to send you connections, can you make 1,000 connections to Oracle? You probably can't. So RethinkDB was built from the ground up, and it has a lot of low-level decisions that were made early on that really facilitates the ability to even do this kind of real-time push without just completely grinding to a halt. And because we do all of that work, you don't have to do that, and it's solved once and it's solved forever. Your applications just transparently take care of this the same way Mike's demo app was showing it. So to take a quick aside here, how do we get scalability and push, to really be how do you build a push architecture from the ground up? Number one piece that you need is the kernel to cooperate with you. Epoll is an interface on Linux, and KQ is the interface used on BSD and Mac. And these allow you to basically say, all right, I want to listen on 1,000 sockets, and just tell me as soon as one comes in. And when I ask you, how long does it take you to answer, does any of those 1,000 sockets have anything for me right now? And with, in the 80s, this was a linear operation. If you wanted to know if any of the 1,000 sockets was ready to give you information, it took you O of 1,000. So with these interfaces that were added in the early 2000s, now you can actually immediately, efficiently in the kernel find out whether any of your stuff that you're listening on is ready for you. So that's the first piece of the puzzle. But that's a pretty low-level piece. The second part is using coroutines instead of threads. So unfortunately, kind of a little bit more explaining than Epoll, but I probably glossed over Epoll too. So the old model web servers, if you're familiar with how Apache works, a request comes in and it pops up a thread, maybe a process, depending on the web application. I think Apache definitely does threads, though. And for each incoming request, you open a new thread, and that's pretty convenient because then you just do your stuff, and then the thread dies. But and threads were pushed into this job, but really threads are really good for CPU heavy tasks. You can write your code and not worry about whether you're totally dominating the entire machine. You just write your threaded code, and the operating system will, do round robin, switch between them, and make sure that everybody gets a fair share of the CPU. So threads are really good for that because it simplifies a lot of code that, if it's CPU heavy code, that just takes care of it for you. Processes and threads though require a lot less memory, and threads have a little bit of overhead memory, but they have much less than processes. But both of them suffer from the fact that they have to switch back to the operating system. So a lot of people think of context switching, jumping to the operating system, as being slow. Actually, that's kind of fast these days. But the scheduling is really slow. Scheduling, the operating system has to figure out who's the fairest next job to run, and that takes a bit of time. And then it, of course, has to jump back to that new process and start there. So context switching is really expensive in threads, and if, in a web app, you're doing basically a whole bunch of I/O. You're basically going, all right, is something coming in on my socket? Great, take it here and send it to that socket. That's almost no CPU whatsoever. And so in Node and stuff, they realize this is a really good application. Actually, this is what I'm forgetting the name of the data, but it's the alternative to Apache. Does anybody? Huh? Nginx, that's it. Yeah. So Nginx is built on Epoll, and it takes care of this realization that basically we're just serving files off the server. Most of the time, we don't need a lot of CPU, and so we don't really need a thread per request coming in. And the fact that we're really I/O heavy is exactly why slow languages like Ruby and Python are totally cool to build web apps in, because you're not spending most of your time doing CPU. So threads and processes are kind of, they're pretty heavyweight in web applications. And like I said, we're just reading and writing on sockets. So coroutines is how they do it in Node. But you can do similar things in other languages. Go routines, I guess, in Go. So, but yeah, so everything's in user space. So you know that, okay, this socket isn't ready to read on yet, so we'll just go to this next one, and you don't have to ask the kernel who to run next. You do it yourself, and it's much faster. And since you're the application, you have a much better idea of which things are ready to run next. And as long as our CPU usage is light, there's not a whole lot of problems. Basically, you'll do some I/O, maybe a little bit of changing the data, maybe rendering some HTML or something, and then you'll be done. It won't be a very long time between when you're done doing I/O and when you're doing I/O again, waiting for another request to come in. And so this kind of strategy is called cooperative multitasking. Instead of the operating system taking control from you and giving it to some other thread, you're saying, I'm done now, and whoever else is done running. And this works great as long as you're not going to take very long doing your thing. Side effect of this is that you don't have any locks or mutexes, which people in Node know is great, because you don't have to worry about anybody taking control of you while you're doing something with a resource. So combining Epoll, the kernel applications, and coroutines, then you get this pattern called I/O loop or a reactor, where you have one guy listening on the socket for anything coming in, and then you're just dispatching it to these coroutines, and they return very quickly, and then you go back to listening on the socket. So you can spend most of your time being completely dormant. And so the important part of this is that it's push. You only are really doing activity when data is coming in. If there's no data coming in, your application is just sitting there, not taking up any CPU, not polling anybody, not doing anything. So that's really that's the part that's really allows you to do a lot more connections in Node, and with Nginx and stuff like that, is because they're not spending a bunch of resources per connection. The resources per connection are very, very small. Okay, so does coroutines work well in the database? Okay, so we've got the front end, we've got the web sockets, we've got the polling in the middle. or we've not polling. We've got e-polling. It's much better than polling. Uh, so we've got this, IR loop reactor in the middle of our web app doing all the stuff. So, the other big piece is the database. Can we use coroutines in the database? Well, it kind of depends. So it sort of depends on. Well, you can do them. No one will stop you. But so the question is, like, are they worth the extra effort to implement coroutines? Because you do have to take some extra considerations. If you're doing a lot of CPU-heavy stuff, which databases do from time to time, you have to make sure that you're yielding control to the other coroutines and not just totally monopolizing the CPU so that everybody can get their queries coming through. And for most databases, it's not worth the trouble because they'd have to do this extra implementation, and queries are so often CPU bound that it's just a lot of work, and the benefit is you get some more connections to the database. Who cares about connections to the database? So most databases, Oracle, Mongo, MySQL, Postgres, everybody you've ever heard of, except for us, pretty much does not use coroutines in the database. They fork off a process or a thread per connection coming in. And so connection pools are really common because you can only have so many connections open in the database before it starts running out of cache memory, and that impacts your query times. So RethinkDB, as I've been sort of alluding to, it builds coroutines. It's very useful because we have, with change feeds, it's really nice to be able to just leave a bunch of change feeds open to the database and not have to worry about using up all the resources of the server. So that's basically why we really need coroutines in the database itself. It's extra implementation work for us. We do have to make sure that we're being fair to all the incoming queries, but it allows us to keep thousands of database connections open and just mostly idle, but then when something comes in, we can just push them out. And everybody can get push notifications instead of having to poll. So it's also something that's really hard to decide later, oh, I want real-time in my database. This is something that's all throughout. You basically have to recode your entire database to do this. So our database does from the top to the bottom. We do coroutines, and everything is in this paradigm. So it really it's something that is architecturally difficult to just kind of say, oh, let's just add it later. Okay, so one of the big takeaway, if you forget all the other crap I said today, connections are really cheap in RethinkDB. So if you want to open a connection per server or per user and have 5 change feeds on that server or on that connection, all the different things that user wants to listen to, that's totally cool. It will take resources on the database, but it's not going to be a ton. So it's a totally reasonable strategy. And as you scale out your cluster, you can connect to different parts of the cluster and get, you get the same scalability, so you can keep. So let's say a RethinkDB single server is able to manage about 5,000 connections. I don't know if that's the right number or not. But you add another server to it, you get another 5,000 connections. It scales with the number of servers you have in your cluster. So Mike kind of touched on this a little bit, but why is the database the right place to push changes to your app? So the big one that he mentioned was, it's a single source of truth. You're already storing everything there. All your events are coming in. So it's a natural place to sort of have notifications coming from. But another thing that's great about having the database be the place that's pushing your stuff is that it already knows, it's already taken your query apart. It already knows which parts depend on which data. It's already put them into its native data structure. So it can just, it doesn't have to do all that stuff every single time. It can decide certain parts of the query aren't not going to change, and it doesn't recalculate those. Whereas, let's say if you're polling, you go, okay, aggregate this and do this. Let's take the top 3 or whatever. You have to recalculate that every single time you do that query, whereas RethinkDB can be very lazy and go, I only need to know this to know whether somebody's fallen out of the top 3 or not. So it can be more efficient about recalculating changes than you can be from the outside not knowing the structure of the cluster. It also knows where your data is located. So basically, if you have one shard and that's the only places your change can come from, then RethinkDB only sends messages to that shard. So it really allows you to have a fully event-driven stack from the back to the front. And you can get the snapshot of the data you want and then just get the updates as they happen in real time. So it's built from the bottom up to be able to enable that and complete the puzzle of a back-to-front event-driven architecture. And yes, and it makes them dramatically easier, as Mike showed you. Like it's basically the same query you would have written, write dot changes on the end. Suddenly you've got a real-time app. Like that's like a level up. It's pretty awesome. So check it out, rethinkdb.com. And if anybody has any questions.